subcommittee with USGIF, along with Chris Powell. We had a couple lightning talks this morning. I hope you guys all enjoyed those. We have a lot more teed up very shortly. Overall this year, we had a little less than 50 abstracts submitted. A lot of interesting and innovative technology happening right now. Change is not always easy. I find in the workplace, but we must, as a community, continue to adapt and evolve in this ever-changing world. So I hope we have 7 presentations. They're all 7 minutes or less. I hope in the next 50 minutes or so, you're able to think about the technology these folks are presenting and how you might be able to incorporate that in your daily workflow and work practices. With that, I'm going to turn it over to George Demmy of TerraGo.
So if you take the words in the title and mix them up and create new technologies and things like that, it's stuff that we use every day at TerraGo, maybe not so much the augmented reality part, but I'm not really an expert in any of those things. So when Scott Lee submitted this abstract and told me that I was going to do the talk, I dug in very, very quickly to find out something that I think would be topical, keep on topic, and then also be of interest to everyone here at the GEOINT. Now, as I started digging into this, I very quickly got into the nature of reality. And what brought me to that was an article in The Atlantic. It was fairly recent about the work of Don Hoffman, a cognitive scientist at UC Irvine. And what Hoffman did was create a model of the world, put actors in it, gave them senses, let them move around, and see what happens. Now, cognitive scientists often posit this objective reality, right? And that the senses that are better at generating an accurate representation of that objective reality are evolutionarily more fit than senses that are not. Well, it turns out that contextual reality, an individualized perception of reality, where perceptions are mapped to actions that have favorable outcomes, in Hoffman's model actually outperform the reality-based actors that people generally think about. So this perception-reaction dynamic got in my thinking about, so how can we use AR to our advantage? And it got me thinking about the work of John Boyd. So if you haven't heard of John Boyd, he's an interesting guy. Check him out. And so what I want to do was take some of the ideas that Boyd came up with and apply it to these models that Hoffman had. And so Boyd is perhaps best known for his OODA framework, where actors observe their environment, they orient themselves to it, they make decisions, and then they act. And if in conflict, you can act, changing the environment before your opponent can orient, decide, act, and can do that repeatedly, you're still going to be inside your opponent's OODA loop. So that seems pretty interesting. So how do we apply this to augmented reality? Well, how can we take augmented reality and use that to shorten OODA loops? That was what I was kind of interested in. And then when you start thinking about it that way, what you have is you've got perceptions on one side, you've got actions on the other, and ways of mapping perceptions to actions, so this little formula. On the perception side of things, you want to perceive what's relevant. You might want to filter out what's irrelevant, right? Then you've got a mapping to appropriate actions. And so this focus on trying to reduce OODA loops to perception, action, almost reflexive things using augmented reality is something that I'm calling tactical augmented reality. And I just made this up. And the reason I did was because I don't know about all the other things that augmented reality should be, could be, already is, can do, hold up your cell phone and see where things are. What I'm interested in this talk here is how do we shorten those OODA loops? So the sensory perception killer app today is probably night vision, right? But then how can we add tactical AR capabilities to existing systems? Well, imagine painting friendlies blue in a non-spoofable, secure way. tracking neutrals as gray, but what kind of sensor networks will we need? Then you've got something like Bitch and Betty and F-18, which can protect pilots from unperceived threats without them knowing what those threats actually are. Roll right, roll up, things like that. So adding these different capabilities to these existing systems is a way forward. So one of the consequences of Hoffman's mathematical modeling, this is kind of future stuff, is that individual observers can be put together to create a new observer. So is there a way that by combining the perceptions and the reactions and things like that, is there an emergent higher intelligence that we might be able to exploit in both directions, both to get more of a strategic understanding of the battle space, then also to help direct the actions of the individual or collective folks in our soldier sensor swarms? So what's next? My PhD would be revoked if I didn't say, more money for research. But what I do think that we can do to enable cloud-based augmented reality networks moving forward is a very, very tight focus on tactically enabling our individual warfighters to make quicker decisions at the kind of that perception reaction level. So thank you very much.